Okay, I want to show you a really quick crash course into deploying, editing, and deploying a smart contract to Katana using the special case starter kit and some AI assistance. So I have here in my sources, I have here my Katana payments contract. This is a contract I wrote for a Telegram game that I'm working on for fun and for demos. And right now it takes ETH as payments. What I want to do is I want to do the following. So I want to add AUSD for payments instead of ETH. And I want to make sure that I have a deployment script ready to go so that I can also deploy this contract both locally and to the live mainnet. So here's what we are going to do. First of all, we need to make sure that our SuperDocs MCP is enabled so that Cursor can very easily find the information it needs. So you can find this in your Cursor settings under MCP and integrations. You'll find that I have added the SuperDocs. If you do not have the SuperDocs MCP enabled, you can just do it by visiting the SuperDocs and finding the information for enabling the MCP server there. So that's superdocs.katana.tools, and you'll find all the info there. Next, what we're going to do is we're just going to tell the AI what we want it to do. So I'm using GPT-5 Max here, thinking mode, and this is the one I prefer for long-form tasks. The development and thinking can take a while and it consumes a lot of context, but I find that it gives the best results. If you want something more granular, like a piece of task by piece of task, piece by piece, then other models are good as well, Opus or Sonnet. But I find that GPT-5 is very good at long-form tasks, even though I sometimes do have to fix some mistakes and so on. But it does speed up the workflow meaningfully. So it's also important to let it know what it can do and what it should do. So here's what we're going to do. I'm going to tell it the following. Learn about the project, because this is a new chat. It doesn't really have any context yet, but all the context it needs is contained in the README file. So from README, and then replace the need for ETH for payments in Katana payments with AUSD. This should apply to all payments. ETH should not be the currency of this contract anymore. Everything should happen with AUSD. Then we also need to tell it what AUSD is. You can learn the mainnet AUSD address from the SuperDocs. When using interfaces, include the ones we already have in this project, e.g. AUSD interface can be included from iausd.sol. So this is from contracts tokens, just so it knows where to find the stuff it needs. And so now it can put all of these things together. And finally, we also want it to write a deployment script. Once this is done, create a deployment script in script, forge script, so we can deploy this contract both to our local Anvil chain and to mainnet. And here we go. We just launch it and then, keep our fingers crossed and see what it comes up with. Anything it comes up with, we can debug and fix and polish as it outputs the information that we want it to output. At this point, the AI is pretty far along. It managed to make some updates, or at least it keeps in mind what it has to do. And now it's reading other files for inspiration on what it has to do to actually complete this puzzle. So we're giving it some more time. So the AI is done. Let's see what it did. We see here that it went through a process. It changed the Katana payments contract and removed more files than it added, more lines than it added, which is interesting, which we'll take a look. And it made a new script, right? So then it tried to compile things, but it ran into issues because it couldn't find the contracts. So then it modified the Foundry TOML file to also include allow paths to also include the contract that we have included in the starter kit. This is a kind of like a mini bug on my end. I will make this sure this is a default, and it's nice that the AI found it here. Then it tried to compile, but it found some checksum issues in some of the address catalogs that we auto-built on bootstrapping the special case starter kit. This is of no consequence to the logic, but it's nice that it found this and then decided to fix those checksums. So again, nothing to worry about. We'll make sure that this is gone in the next push to the special case starter kit. Of no consequence at all. Then it made the other changes, and so let's see what it actually did. Here it explains everything that it did, and how to deploy this. So let's see which files it edited. So here we have the Katana payments file, the script file, the Foundry TOML file, which we already saw. The Tatara addresses, checksum fixes are here, nothing meaningful. This will not be in your example if you try to reproduce this. But the important ones are here. So Katana payments.sol and Katana payments script.sol. So let's see the Katana payments one first. Here we have it imports correctly the AUSD interface from contracts tokens AUSD. And if we actually visit this interface, you can see that it has all the information. AUSD is indeed an ERC20, and the custom tags here define its addresses, which is also where the AI got the address for this token. So that's all well and good. Then it added a new error for transfer failed. It then makes a new variable for AUSD, and then later on it modifies the constructor to kind of have this AUSD reference so that you can actually pass in a custom AUSD address if it differs on your blockchain. In this case, we don't really care much because we're only focused on Katana, but it's nice to see this versatility added in. It then removes some functions that we no longer need because this was only for ETH. So if you send more ETH than you should be able to claim a refund back out after this. But since we're dealing with token approvals and pull logic from people's balances, then there is no way for them to send extra tokens, and so there's no need for the refund functionality. This is where the difference comes from with the deleted versus added number of lines. Then we have the top-up functionality. Everything has been topped up, everything has been changed to respect AUSD now. One thing that we have here, and this is Wake, Solidity Wake, this is the plugin for VS Code that analyzes code and finds vulnerabilities, that it flagged down, is this unsafe variant of ERC20 call. So this is an interesting fix, which we are going to deal later. It probably wants safe transfer from versus transfer from, but we'll see what it complains about. Then we have the top-up mechanics. Again, the same error flagged by Wake. Nothing critical, but it is noted here. And then we have some other details that it's changed to make it all compatible with AUSD. So at this point, we have the entire contract edited, and now let's see the deployment script. So the deployment script itself is fairly simple, but it's tedious to write, so I prefer to let AI write this for me because it's as boring as writing tests. So now it created some helper functions here, and then it kind of gets these environment variables if they exist. If not, it just takes some sane defaults. In our case, if we do not provide the chain ID, it will just pick Katana chain ID, which is 747474, and the appropriate address from the chain. This is good. Then it will take some sane defaults for the logic of this contract, which means it will set the top-up price to 1 AUSD, $1, and it will do some other variables setting which are native to this contract that we have. And then it will call this contract deployment and output the values of our deployment process. And now we can try to deploy this after we click keep all. So now we've kept all of this logic that it wrote, and now we can check it out. So how do we deploy this script? Well, this is documented in the README. So if you go to README and down into the Forge section of the README, Foundry commands, you will find that you have here the deploy script. The regular Forge deploy also works, but I've kind of abstracted it here behind a bun command, which I will show you now, but you can use any method that you feel comfortable with. So the command you need to pay attention to here is bun run forge deploy minus minus, and then you have here script Katana payments as sol, so that is the script file that it wrote, and Katana payments script, this is the name of the contract that does the deployment. Then you provide the chain Katana and a private key if you're deploying to the mainnet. If you omit all of this, then it will default to the unlocked anvil key and to the default locally running copy of Katana on localhost 8545. So you can technically just run this bun run forge deploy, the script, and chain local. So let's try running this now, but first we need to spin up our chain, which will be done with bun run start anvil Katana. So now that I do this, it has gone online, it has copied the state of Katana, and now I have a locally running blockchain in my memory with the current live state of Katana. AUSD exists on it, everything is as it is on the mainnet. And now we can try, you can see it is producing blocks. Now we can try launching the deployment script on local. We will use our other terminal for this. And there we go, on-chain execution complete and successful. We see here that the contract address is here. It has been published to our local blockchain with the unlocked demo account. And this is how easy it is to modify a smart contract with AI in a secure way and deploy it to your local chain in just a few minutes by utilizing the full context of the special case starter kit for localized Katana knowledge for your AI tools. I'll see you in the next one when we will build a simple UI for this contract, also with the help of AI, so that we can actually interact with it in our own little UI.